Good afternoon, everyone. Uh, my name is Professor Henry. I am talking from my lab on behalf of M-Tutored. Today we are going to see a topic, basically what is science, engineering and technology. This being my first live stream, if there is any mistake or anything, please do pardon me, because I am also a little bit nervous doing it for the first time. So I will try to, in a small amount of time, whatever possible, I will try to explain to you. I am currently standing in my lab, which is basically for satellite design. We have, in a hurried way, arranged few things so that we can give a better explanations. Basically, in India, we have 16 lakhs engineers passing out every year, and this has been the case for last 20 years, we can say, from the start of privatization. And science education has also been encouraged in the last 4 or 5 years with the establishment of Indian Institute for ISER, like Indian Institute for Science Education and Research. So, but still, many of us choose engineering or science or whatever the profession or the passion only for the sake of jobs, majority of us. So there has been a clear mismatch between the passion and what they are actually studying on ground. So it is imperative that everybody understands what is the difference basically between science, engineering, and technology. Not only the differences, but they are also able to correlate how these three things are related. Okay. So basically, if you look around my lab, I can just move it around the round. So there are some toys I have assembled together for you to show so that you can visibly see. They are my students who are standing there. And also, you can see the other components we have. We have a live 3D printer here. There are some telescopes, a small prototype of 3D printer is also there. And what is this? What is this? This is technology. For example, 3D printing is technology. But then what is basically science? Science is the ability of the human species. We are Homo sapiens. Basically, we are Homo sapiens sapiens. That's our technical name, zoological name. And basically, we are one of the most intelligent species, we could say, as far as now on Earth. And we are using our 1,400 grams for adult brain, male brain, and 1,350 grams for a female brain. And using this brain, the cognitive abilities, and using our 5 senses, we are able to understand what's going on around us. Yeah, basically we are able to understand what's going on around us, and that is nothing but the science. So we can define roughly science as the ability of the human species to use its cognitive abilities, degree of intelligence, and the 5 senses to understand what's happening in the universe. If that is going to be the science, if you take our universe is roughly 14 billion years old, 13.7 billion years old, and our Earth is 4.6 billion years old, and our human species on Earth is only 200,000 years old. So we are one of the youngest species on Earth. So using these abilities, by understanding what's happening around us in terms of science, we have developed certain tools and crafts which can assist as well as improve our standard of living or provide comfort for living, that we can roughly define as technology. Okay. So this technology are the tools and crafts developed by Homo sapiens for improving their own standard of living, but most of the ideas comes from nature. Then what is engineering? Engineering is the process by which we connect science and technology. Engineering is the process by which we build this technology. For example, I will give a very simple example. Many of us have seen the birds flying, right? That is aerodynamics. That is a basic science. Okay, pitch, roll, and the 3 motions, the 3 different directions in a 3-dimensional space in a fluid. So that principle we have been observed by watching the birds or anything that could fly in the fluid in the atmosphere. So that is the basic science, aerodynamics, basic science. Now using by this understanding, the Wright brothers and others also tried at the same time, were able to build an aircraft to fly, right? Something like this toy model which I happen to have here. Okay, this is a toy model of an aircraft, right? A simple aircraft, right? Now same way, this is a which goes in a linear fashion and takes off. And then we have vertical liftoff. So these are different technologies which have been derived by using these principles, yeah, by understanding this science. These are what we call technology, aviation technology. But how did we build this aircraft? How did we design this aircraft? How did we construct this aircraft? And that is aviation engineering or aero engineering. I can give another interesting example to make you understand the link between science, engineering, and technology. For example, we are all able to see light with our vision, so that is basically optics or optical science. And we are also able to visualize different spectrums of light. That is a visible spectrum, that is 400 nanometers to 700 nanometers. Right. Now, that is optical science. How can we see light? Basic science is optical science. But using this optical science, we have been able to develop prisms, lenses to manipulate the properties of light. Because light always travels in straight line. It cannot be bent. But still we have been able to manipulate the traveling and the speed and the velocity of the light, modulate the light properties. So we have developed new technology like photonics. Okay. But how did we build these optical components by prism, lens, etc., or photonic devices like fiber optic? For example, you can see in our lab, we have a fiber optic core here. So something like this. So these are different types of single mode, multi-mode fiber optic cables, right? So we have been able to invent such kind of cables, or these are the technologies, photonic technology or fiber optic communication technology. But how did we build this fiber optics? How did we build this lenses and thing? That is optical engineering. So optical science, optical engineering, and optical technology or photonics are different technologies. So that is the link between science, engineering, and technology, right? So I already told you our universe is 13.7 billion years ago, and we also should understand how this technology, how we are able to exploit the property of matter for different dimensions. That is very much an important aspect of it. For example, you take a 1 meter long copper wire, any copper wire, something like this, or I can show it in my lab, a copper coil, a long copper wire, and you give a voltage to it or current to it, it will conduct electricity, right? The same copper wire, if you cut it through smaller dimensions, very, very small dimensions, the same copper wire at a very, very smaller dimensions, say beyond 1 nanometer, may not conduct electricity. Basically, they change their property with dimensions. For example, everybody knows about carbon, okay? For example, graphite conduct electricity, but normal carbon, other types don't conduct electricity. But a buckyball or a carbon nanotube can conduct electricity, okay? So they can conduct electricity, something like this, yeah? So the property of the material changes with dimension, and we are trying to exploit this change in property to develop different kind of technology, right? For example, I will give a very simple way to explain this would be, when we talk about technology, we call it microtechnology, nanotechnology, picotechnology, femtotechnology. These are different types of technologies, but they are all exploiting the different dimensional properties of matter. The different dimensional properties of matter. Now I will try to give a little more in-depth understanding of this science. I told you science is literally just the understanding of the real world using our 5 senses and cognitive abilities, right? That is not the only case. But this science word itself comes from the Greek word scientia, right? And scientia meaning to look for, right? So basically we are using our cognitive abilities to understand the different laws and phenomena which are happening in the universe. But a systematic research should be observation and analysis. That is research. There are only basically 2 types of sciences: natural sciences, social and behavioral sciences. Natural sciences in the sense physics, chemistry, and biology, and formal sciences like mathematics and law. And social and behavioral sciences, how we humans interact among ourselves and also with the environment. So science basically leads to collection of intelligent data, that is nothing but knowledge, right? So is that all sciences? But for our own understanding, with the more we discovered over the years, 2,000 years, 200,000 year species, we have evolved so much that natural sciences, formal sciences, and social sciences. Under natural sciences, we have physical sciences, physics and chemistry, which talks about molecules and atoms. And then we have earth sciences, ecology, which talks about environment, oceanography, which is about study about the oceans, which everybody knows, geology, which is study about the lithosphere, basically minerals and everything, and meteorology, which is study about the weather, right? Similarly, we have life sciences. Life sciences includes zoology, botany, medicine, and also biology, generally biology. Okay. Now, in case of space science, we have astronomy and outer space science or space science. In astronomy, we are going to be on the ground on Earth or on a space telescope or on a ground-based telescope, something like this you can see in my lab. We have a couple of ground-based telescope. I hope you can see them, professional telescopes. So these kind of telescopes are on the ground, and they can be used to observe the planets or the stars which are in this, which are very, very far away from here. So we are on the ground, on the Earth's surface, and we are trying to understand what's happening in the other planets or other regions, right? So that is astronomy. Or we can also use space telescopes like Hubble Space Telescopes or James Webb telescopes. It's different kind of thing. Okay. Then outer space means once we cross, this is the basic structure of the atmosphere around the Earth, right? So we have the stratosphere, troposphere, mesosphere, and ionosphere, and then we go to the outer space. So anything above 400 kilometers after crossing the ionosphere, and we are able to we define it as the outer space. Okay, so that physics is totally different. That is outer space science or space science and astronomy. Then we have formal sciences. Formal sciences are nothing but the ability of the human species to develop some representational language to understand and count and analyze things. That is mathematics and logics. They are the foundation of computation. They are the foundation of calculation. They are foundation of analysis. Even physics, chemistry, biology, everything is basically comes down to our intellectual ability to represent the external objects and classify them, analyze them, and compute them. So that is where the mathematics plays a very important role. That is the foundation of everything. Then we have social sciences where we talk about where we talk about anthropology and archaeology. Okay, these are all the general way of categorizing science. But science is the end of the day what we can understand using our intellectual ability. That is as simple as that, right? Okay. Next we'll talk about technology. As I already told you, technology is nothing but the tools and the crafts developed by the human species by understanding some science to improve their own standard of living. Technology includes different kinds of techniques and technical productions. The technology word itself, application, comes from a Greek word called technologia. Okay. So what is the basis of technology? Technology has allowed the human species to adapt and control the environment by creating modern tools and crafts. This has been happening for 200,000 years. From the time they moved out of Africa, or even moving before out of Africa, they invented the stone tools, the fire tools. So our species have been able to learn from the nature and create new artificial tools, man-made tools that can be used to improve the standard of living. So we have created many different kinds of systems. As on date, we have only 4 functional technologies, broadly understood as technologies. One is information technology, which talks about bits and atoms, basically computing platforms, okay, where the building blocks are zeros and ones. Then we have biotechnology, where we have been able to create application based on the biological systems and biological entities. So that is biotechnology. Then we have material technology, like nanotechnology, where we can use and exploit the dimensional aspect of materials to have new kind of applications. Like I told you already about an example. Carbon is a non-conductor, but at a nanometer level, the carbon nanotube conducts electricity, right? Then we have cognitive technology. We are currently at this right phase where cognitive technologies, we are trying to replicate the functionality of our central nervous system or the cognitive abilities. The ability to think, the ability to talk. So artificial intelligence, machine learning, robotics, okay, optogenetics. These are the different kinds of fields where we can interface our functional human brain with an external system, at the same time also developing systems which can mimic the activities of neurons and central nervous system. So that is cognitive technology. They are called the 4 pillars of technology. So any device or instruments cannot be built without the convergence of these 4 technology. From a mobile phone to measurable glucose meter, Everything is basically dependent upon the convergence of technology. For example, the glucose meter measures, it's a biological but this biological sample but this biological sample but this biological sample is being measured by a chemical reaction. Then it is being displayed by using an embedded system, right, on a LCD display or a monitor, whatever you call it. So everything is a convergence of technology. For example, if you take a simple touchscreen mobile like this, okay, touchscreen mobile like this is a polymer which is sensitive to touch, capacitive and based or resistive based touch screens. So these are also convergence of technology, right? For example, you take a silicon wafer like this, for example, a silicon wafer. This silicon wafer is further developed into our IC chips, right? For example, like this, right? It is nothing but a sand, but it involves chemistry, it involves metallurgy, it involves all the branches of technology to come out with a single chips using lithography, which is called the heart of microfabrication, right? Okay. So that is why the convergence of technology is essential, what we call BANG, bits, atoms, neurons and genes. This convergence is what is going to take us ahead. Already in the Indian market, we have been hearing about a lot of news about the software service industry has been at the back end recently because of machine learning and automation. So that is one of the greatest progress in the humanity, if you take it in a positive approach, to invest more into cognitive research and cognitive related disciplines like machine learning and artificial intelligence. Okay. So technology is not something new from the human species. For example, if you take 4500 BC, we started with the Stone Age, we followed with the Bronze Age, then we followed with the Iron Age, then we followed with the printing, which was in China, and around 1600 the birth of the Western science or Renaissance period, 16th century to 20th century. We talked about modern Western science. That is what we are following, from Max Planck to Isaac Newton to everybody, all the great physicists, chemists, and the biologists. Most of them come from Europe. Yeah. Then it was followed by 400 years of the growth, and they ended up in the industrial age. That is, then came the that is with the invention of James Watt steam engine. Then in around 1971, the first Intel microprocessor came into picture, and that started the complete revolution of computing. And today we are talking about a handheld platform like a mobile phone or a smartphone, wherein the processor plays the important role. So it can be a microcontroller or a microprocessor. Whether it is a Samsung or iPhone or any kind of modern smartphone, it can be an ARM7 core, which is a microcontroller, and ARM9 core. Okay, and most of you are using laptops, computers, and everything. They are all made up of these processors, right? So that started in 1971 with the first Intel microprocessor with 1,000 transistor with 1 hertz operations in an area of 1 centimeter square. So with using a technology where the building block of these processors were MOSFETs. Okay, and that technology, the distance between the source and the drain in the MOSFET was more than 189. Very, very old technology, right? Today we are slowly around 2012. We have started with the Nano Age, where we are going to exploit the change in the dimensional change in the materials to exploit new kind of devices, that is Nano Age. And we are expecting to have a proper cognitive age where we can be able to replicate the functionality of cognitive abilities of a human brain. For example, today we have functional magnetic resonance imaging, which is able to image what we are thinking and process, right? Similarly, we also have optogenetics, which can obtain using optical stimulations information from the nervous system, which are far better than electroencephalogram or electrocardiography, right? So this is the beginning of the cognitive age, and we believe by 2050 and beyond, the real space age will start where we will be able to travel to other planets very freely. That basically depends upon how we are going to develop our rocketry system and different kind of systems, right? Okay, so that is the basic timeline of technology. Then we come to the basic aspect of engineering. So what is engineering? Engineering is a basic process, or the process by which we build this technology. Design and construction. The meaning of the word engineer basically means one who constructs. So design and building structures is the basic ideology of engineering. Okay, they are basically based on the natural laws and physical resources. So we design and construct and create a technology. For example, once the basic aircraft were invented, it was followed with vertical liftoff, horizontal liftoff, and different kinds of aviation technologies. It's multiplied into different applications, different sources. So that is technology. How we build this aircraft? How did we design? How did we obtain, design and constructed this aircraft? That is aviation engineering. So basically, engineering is about design and construction. Okay. there are only basically 3 or 4 branches of engineering: civil, mechanical, electrical, and chemical. Okay, all others are only derived from these branches. Unfortunately, in India, in the expansion of the IT industry, IT service, not IT industry, IT service industry, in last 20 to 25 years, the number of branches have been increased in the undergraduate and the postgraduate education, right? So basically, we have innumerable subjects, but at the end of the day, what is required is very much less. Yeah. So only this 4. So that is the connection between science, engineering, and technology. Where our education system has failed, why we are not able to invent a product. For example, you take a television, you take a radio, you take a mobile phone, you take a computer, Intel. Everything is being made in the West. If you take your physics books or a chemistry books or a biology book, from Max Planck to Newton to Isaac, every contribution in the modern science, I'm only talking about modern sciences, have been always from the West. And we are today following from our movies, our music, our our way of dressing and talking, everything is based on the modern. It is not that we were very bad. 5,000 years ago, we had Mohenjo-daro and Harappa culture, yeah. So we were able to build temples, 2,000-year-old temples, whether it is in the east, west, north, or south of Indian subcontinent. Everywhere we built beautiful temples without importing equipments from abroad, yeah. Somewhere we have lost the track of this alignment of the connectivity between science, engineering, and sorry for the message, science, engineering, and technology. That is what one of the reasons why there are so many engineering colleges in India getting closed down in the recent times, which you have read in the newspapers, because most of the engineering colleges don't give as much importance. That is, you have to give equal importance to practical as well as theory. Whatever you learn, you should be able to apply applied intelligence. Okay, that is one of the drawbacks of our country. But still, India has achieved a lot in the last 70 years after independence. We have been able to launch 104 satellites by ISRO. Yeah, we went to Mars, we went to Moon, but that is only by meager 10% of the population. The remaining, imagine a country of 127 crores or 1.27 billion brains, if they can innovate and invent within our country and create products where we are able to sell it to other countries standing in a queue to buy our product instead of we standing in queue to buy a Rafael technology or something else. That is where the real India will start. That is where the real made in India will be there. Not make in India, it is a real made in India where we sell our products, where other countries stand in a queue to get our visa, come and learn our technology. Like we are now totally dependent upon American product. Though we call it as a globalization, where we are running, many of our IT service industry are running our services, they have to evolve into product-based companies. If all these companies could have invested 10% of their income into or their profit into R&D today, we could have sold an ML-based product, that is machine learning-based product for any of these big companies outside India also. Anyway, that's a different topic altogether. So basically the understanding goes like this, and whatever is going to happen in the future is basically based on this convergence of bits, genes, neurons, and atoms. That is for definitively going to happen. Okay, so already I explained about the change in the dimensions, and when the material dimension changes, their property changes. When this property changes, we are able to exploit this property to create some kind of new applications. Yeah, so that whether it is in the smaller dimensions like picometer, femtometer, attometer, zetometer, or ectometer, or in the reverse, a kilometer, megameter, hexameter, or zetameter, or atometer. Okay. And specifically talking about information technology, because we have been obsessed in India with information technology. And if you see, the information technology was coined only in 1981 by Jim Domsick, sorry for the pronunciation. And it doesn't start, but it is not just about computing and software and services. Okay, and information technology encompasses a broad amount of area, starting from microelectronics, like this, like this, microelectronics, or an Intel board, or the IC chip. It starts from the basic microelectronics. But this microelectronics is based on the basic electronics. Basic electronics means electron movement, basically electron movement. So whatever resistance offered to the flow of electron is resistors. Then whatever ability for a structure to hold this amount of electron, that is the capacity to hold the electron, is the capacitance or the capacitors which hold them, the devices, and the kind of devices which can induce or generate the electrons to start, that is the inductance or the inductors. Then for the cognitive technology, we have the memory resistors which have the ability to retain the memory like our neurons. That is for the cognitive technology. So this, if you combine two resistors, serial and parallel, along with two capacitors, you are able to build a equivalent circuit of a diode. If you combine two diodes, PN diode back to back, you get a MOSFET. If you combine two MOSFET back to back, you get a CMOS. If you interconnect millions of CMOS, for example, Pentium 4 has 80 million CMOS transistor in 1.2 centimeter square area, right? That is microelectronics. Okay, so if you combine all these chips, you get processors and controllers. And if you use these processors and controllers for some specific application, then it is defined as embedded system. A mobile phone is a very good example of an embedded system. Right? A mobile phone is a very good example of an embedded system. Right? If you are able to connect a multiple embedded system, for example, if you can see in a screen like this, okay, say a screen of a computer like this, cracked open at the bottom, if you are able to connect this embedded part with a hard disk, which is another embedded part, with a screen, which is another embedded part, then you are making a networking. The networking starts from devices. For example, like this router, which I am using now to talk to you. Right? This router is a very good example of how to network, this wireless networking. So if you are able to network these devices, then you are getting, that is why in your PC you have IEEE port, USB port, parallel port, that port, this port, all these ports are for networking, right? So on top of this networking comes your software where the user is able to interface with this hardware or computing devices. So this whole array that is starting from electronics to microelectronics to VLSI to embedded system to networking to software, this complete array is information technology. See, the beauty of nature is a similar observation can be also done in biotechnology. For example, all the living things are made up of cells, whether it is plants or animals. These cells are in the range of, or for example, tissues. Our heart tissue is different from our lung tissue or from our digestive system. So if you see these tissues, their dimensions are 100 microns to 10 microns and 100 microns to 10 millimeters, right? And if you take the cells which are made up of, these tissues are made up of, they're 100 microns to 10 microns. And if you see cell organelles, nucleus and mitochondria, they're 10 microns to 1 micron. And then we have the cell materials, proteins, lipids, DNA and RNA, which are roughly 10 nanometer to 0.1 nanometer. The diameter of an DNA is 2 nanometers, for example, right? So this is a hierarchical structure. So from tissue culture, we go to cell culture. From cell culture, we go to cell biology. From cell biology, we go to molecular biology. Thus, hierarchy is repeated in every kind of technology as such, whether it is biotechnology or information technology or cognitive technology or materials technology, right? So what we are basically doing, for example, if you take any living matter or non-living matter, yeah, for example, you take a oxygen or a carbon, and if you take a DNA, the DNA is made up of adenosine, cytosine, thymine, and guanine, right? They are nothing but peptides, proteins. Okay, they are made up of nothing but carbon, nitrogen, hydrogen. Same what is present in outside in our atmosphere, carbon in the form of carbon dioxide or different, the carbon, yeah. Same nitrogen is there, but only the presence and absence of life makes the difference between non-living materials and the living materials. If you take an atom and break an atom, you are getting the basic atomic particles, basically electron, proton, and the neutron, right? But you cannot break an electron because electron is a negative integer fermion. It is a subatomic particle. You cannot break it down further. But you can break a proton, you can break a neutron, and you will get quarks. So we have 6 types of quarks. I am not going to the particle physics, but you can, if you further break the quarks, what you may get is only a form of, then we call sometimes, some people using quantum chromodynamics, we can call them as colors. So if you further go divide the material further and further, you are going to the end of E is equal to mc square. There will reach a space where you will be, the matter will not exist, and everything will be as E is equal to mc square. It is equivalent to throwing a ball at twice the velocity of light, then the matter becomes automatically energy, right? So whether it is a living things or a non-living thing, the fundamental building blocks are the same. And this is what happened at 13.7 billion years ago when the Big Bang happened, when all the energy which was conserved in a small area exploded. Within the 10 to the power minus 35 seconds, what we call the Planck's epoch era, all these particles first formed were the leptons or the quarks. These quarks then cooled down to combine to form the neutrons and protons. These neutrons and protons further cool down to form the different kinds of states of matter, right? Then they become planets and stars and blah, 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 and it goes on. So that is the particle physics. So there are only 4 fundamental forces, and these different kinds of particles, subatomic particles, we will not go too much into physics because this is basically, but still we are yet to exploit the properties, of these material dimensions further and further. So where we are standing today? Today we are standing at machine learning and artificial intelligence, which are taking down our IT industry, especially in Indian context. So we have to move on to product-based development. Second thing that is taking a big change is your 3D printing systems. So additive manufacturing or subtractive manufacturing. So this is a very good example of a simple 3D printer, only 22,000 rupees. Anybody can buy it and assemble it. So you can able to build different kinds of toys, or you can build anything. So we have just have prototype for experimenting. So next big revolution is going to be digital manufacturing. So the day the digital or what we call personalized, customized manufacturing. Another important area that is going to transform our world is going to be the bioelectronics, or the beginning of the what we call the basically the combination of electronics with the flesh or the living cells. That has been already taking place in many research centers, but still to an application level, maybe in another 5 to 10 years, there will be big revolutions where we will be wearing our chips on the hand or legs to measure our body temperature or any kind of physical activity. So the for example, I can also give one more example. If you take for example, living cell, all of you are studying about cell wall and cell presence and absence of cell membrane in plant and animal cell. Right, and inside these cells they have mitochondria, something called a mitochondria, which is also called as the powerhouse. Basically, it breaks down the ATP cycle to ADP cycle, ADP to ATP cycle, releasing the energy. That is why we call the energy or the powerhouse of the cell. This mitochondria structure itself can be conceived as a MOSFET structure because it has 3 layers. Right? So this is the beginning of the real bioelectronics, where we are able to exploit the property of our biological systems. Another good example, those who have studied about neurons, especially for cognitive technology, the neurons basically conduct because of sodium, potassium, chlorine, and calcium ions exchange. That is what happens in a neuron. You have axon, then you have glial bodies, then you have the dendrites, which they communicate with another neuron nearby through synapses. Now, if you see how these ions are conducting, that somebody comes to touch you, you are immediately able to feel. One is through perception, another is to the sensing action of your touch. Basically, you are sensitive, your skin is sensitive to touch. So that is nothing but an ionic conductivity or ionic current. Okay, so these ionic current are passing through something called microtubules. What are these microtubules? These microtubules are nothing but alpha beta polymers, right? So there are enormous research going on where we can use this microtubules itself as a diode structure. Right. So in the future, in another 20 to 30 years, you will find lot of these biological systems becoming electronic structures for different kind of applications. So that will be the beginning point where we will integrate electronics with, flesh. So the second thing that will going to change around the world will be the environment. So there has been a lot of talk about disagreements about energy, whether the environment is degrading or not, but every individual can understand what is actually going on around us, and there is a lot of degradation in our environment. So for example, it is similar to say that we may not be able to go to another planet. In 1996, there was a James Bond movie called GoldenEye, where they started showing a touch screen based mobile phone, touch screen based screens, and today it is a reality, nobody remembers about it. Yeah, something like that. Yeah. Similarly, today they are showing interstellar gravity kind of movies. We just laugh at them, but one day they will become a reality. Yeah. But still, in our country, we have a long way to go where we use the basic STEM, that is science, technology, engineering, and mathematics, for our own problem-solving abilities, indigenous problem-solving ability. Most of the product that we buy from the West have been invented or produced or discovered only to solve their own problems. Once they solve their problem, they export to other countries, and that becomes a huge market, right? So we Indians have to invest more energy, more money into research and development, and it is not about how much I can earn a package. Because of this very exponential growth of the software service industry, packages become a big issue in engineering colleges and science colleges across India. Right? So, but otherwise it was a very normal country, a normal developing country. Still we are a developing country. Out of 127 crores, still 30% of the population is living below poverty line. So using our universities, IITs, and all these 3,400 engineering colleges and Krishi agriculture universities, we can solve the farmer suicide. We can solve the problem of farmer suicide by having a new kind of engine system or pumping system, or plants to grow in a very less amount of water. Many of the problems can be sorted out if we apply our engineering and technology skill to solve our day-to-day problem. Okay. So end of the day, it is not that everything is bad. We are progressing as a big country, so there is a lot of changes. But at the current time, we are facing a very difficult time, basically in terms of the IT industry. But it should not be a shock, because our whole country of 127 crores is not dependent on a part of just an IT industry. Right? There are many other things that we can do, and that definitely our country will never ever go down. That is very much important. So that is my basic idea about science, engineering, and technology. And if you have any doubts, you please email or pass a message to mtutor. And I always say the poem of Robert Frost, who, Stopping by Woods on a Snowy Evening, which he wrote in the year 1922, which was the famous lines for Pandit Jawaharlal Nehru. No politics here, but still it was a favorite line, who started the IITs and National Institute of Design, etc., blah, 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 whatever it is. End of the day, the poem ends with, woods are lovely, dark and deep, but I have promises to keep, and miles to go before I sleep, and miles to go before I sleep. So we as a country, like our Pandit Rabindranath Tagore also said, we as a country have grown. Then he wrote in 19... patriotism is not spontaneous, which is inborn. There, where he has a poem where he says, where the mind is without fear, the head is held high. And the end of the poem ends with, into the heaven of freedom, my father, let my country awake. So it is not just make in India. It is not just boasting about ourselves in Facebook or WhatsApp. It is actually the ability to solve our own problems, our own indigenous issues, by using the pure science and pure technology, which we had the abilities 5,000 years ago or 2,000 years ago, like Ajanta and Ellora and the beautiful temples across the south, east and west. So these were all built with the basic science and technology without importing or do. So though we call it as a globalized world, today we can see how conservatism is affecting in the projects coming from Europe or US, right? So as a country, we have to evolve more, we have to invest more, we have to solve our own problems. And this incident which has happened recently in the software reduction or the job loss, whatever comes in the newspapers, whatever we hear from friends and colleagues, is just a passing phase. We can only overcome all this problem and not to be dependent on others for science and technology. The day when we are able to sell our products and our inventions, that is when our country will become really powerful. Thank you. And thank you. If there are any mistake, please do forgive. Thank you. Thank you very much.